Okay, today as we wrap up 2.6, we're going to put this all together on some graphs of these rational functions. All right, now on your test, grading freehand graphs is going to be hard to do. So a lot of these skills are going to be a big part of your problems, like finding x-intercepts, finding y-intercepts, finding asymptotes, and things like that. There's only one or two that have graphs for you to choose. Okay, now these 7 steps look like a lot to remember. So that's why I try to summarize it over here for you. I'd like you to write this down, please, as the success criteria for these. All right, so the first step, you need to simplify the function when graphing these rational functions. Simplify f of x. Second step, basically it's step 2 and 3 over here. They have details on how you find the intercepts, so that's still key. But basically, to summarize it, you're going to find and plot the intercept or intercepts if there's multiple. Sometimes you might only have one intercept or none. Okay. Steps 4 and 5 over to the left are talking about VAs and HAs. Basically, just means find and sketch all your asymptotes, even if we have a slant asymptote. All right, and then you basically don't need a graphing calculator for any of those. You're just going to put all that on your graph, kind of get like a skeleton going, if you will. And then we'll pick up our graphing calculator or graphing app or website to throw it in there and finish the graph. Okay, I've added to that, add more points where needed. We'll discuss when and where it's needed once we do these examples. All right, here we go. Let's go ahead and do example 11. State the domain of the function. It's important, it's not really part of the graph, but it's important for us to go over it so you know the difference between the domain and the vertical asymptotes, as we talked about in our warm-up today. So let's go ahead and start by doing that. Just squeeze that in up here. Part A. What's the domain of the function? It's the zeros of the denominator. What can x not be? X cannot be -1. Okay, so domain is x cannot equal -1. For more complicated denominators, remember we set that equal to 0 and solve it. Okay, all right, so now we get into basically the graphs and all the steps to do that. So we need to make sure we simplify the function first. We worked with this problem a little bit yesterday, and it already is simplified. There's nothing I can do to factor it out and reduce it. Okay, and we already found the intercepts. Here they are. Okay. So on to C. Let's go ahead and find the asymptotes. I'm just going to section this off a little bit so that I got more room. All right, I'm just going to do the asymptotes right down here. I guess I'll start wherever we have room. Let's start with the vertical asymptotes. Vertical asymptotes are the zeros of the denominator after you've simplified it. We've already simplified it. Okay, so the zeros of the denominator, I guess if you need to see the work, x plus 1 equals 0, subtract 1, and we get the VA. All right, so there's a VA at x equals -1. All right, now let's start putting all this on the graph too as we're working through this. So the intercepts, we had it as 0, 0. So this graph crosses through right here. And now we have a VA at x equals -1. So what I want you to do is just kind of draw a dashed line vertically at -1. Okay, what about horizontal asymptotes? Okay, when the degree is the same, reminder of this here, if I find my notes on the horizontal asymptotes. Remember, when the degree is the same, which is what we have right now, we divide the leading coefficients, meaning there won't be a slant asymptote. Okay, slant asymptote, the degree has to be higher on top. All right, so I take the -3 and divide it by 1. So there's a horizontal asymptote at y equals -3. Draw that in there. Go down to -3. Get your dashed line. Okay. All right, now we're kind of to the last step now. Step 1, simplified. Yep, we found our intercepts and we plotted them. We only had one. We got our asymptotes. We sketched them. Now we're going to use the graphing calculator to finish, add more points where needed. This is really kind of part D, plot additional points when needed. Okay, so grab your calculator. I'm going to go ahead and pause because some of you might need to go grab your calculator. Okay, here we go. So we're in y equals. The numerator and denominator should always be separated with parentheses. Since the numerator is only one term, I could get by, but the denominator definitely has to be separated. So rule of thumb, just always close it. It's not going to hurt to do it even when you don't need it in the numerator. Close them with parentheses, okay? So we got negative 3x up top divided by x plus 1 on the bottom. Okay, usually a 10 by 10 window is going to be fine, so that's our zoom 6. Okay, one other reminder too, sometimes if you get an error message, your stat plot might be on, especially in this class in here where I've got statistics and we do stat plots. So that's second y equals, mine's on and I didn't get an error message this time, but to be safe, you might want to always turn that off, okay? So if you got an error message, try it again. Okay, so here's where you're going to want to get an additional point where needed. I don't have any interceptor over here, anything over here to help me. I can definitely see that vertical asymptote though. Remember with that x equals -1? There it is, right? The graph is not touching that. And then here's the horizontal asymptote, but y equals 3. So that helps me fit the curve, but I don't have a good point. I don't want to just come over here and just wing this thing like that. Let's find a point to help me curve it, and we'll be good to go. So just hit your trace button, okay? And then just kind of scroll to the left until we get just something that's on that turn. It doesn't have to be exactly the same one as mine, just as long as it fits the curve. So I have -2.3 and -5.2. So I'm just going to label that down here so you know what I have. -2.3, -5.2. And I'm going to plot that. Okay, now that just gives me a way to fit it. You might be wondering, well, do I need more than that? Not really, because here's how the graph behaves along the asymptote. It's going to get closer and closer to that and not touch it. So I'm just going to start up here. I'm going to bend it through this point, and then I'm going to take it along the vertical asymptote as well. Okay, here's a mistake you shouldn't do. Don't do something like this. Don't bend them through and then bend the graph back this way. It doesn't do that. Okay, get it close or just nestle it in with that asymptote, okay? Okay, and that's it. I'll just kind of make this point pop out a little more so you can see that I included it. All right, now the other one, it's kind of up to you now. You have a point. The intercept serves as a guide, so that might be enough. I guess if you want to get one more over here to be safe, sure. Let me just scroll. I'm just going to hold down the right arrow until this spider gets over here somewhere, and then here's another point. 1.5 and -1.8. So about 1.5, -1.8 might help me fit that a little better. But technically, I probably could have got by without it. And then you can see how it's behaving along those asymptotes again. So I usually like starting on one of the asymptotes. I'm just going to kind of start up here. Maybe put an arrow to show it keeps going. Come through the intercepts, through that additional point, and then I'm just going to nestle it in with this horizontal. Like that. Don't make it cross it. Don't make it bend back up. Nestle it in there. Okay? So any questions on this? All right, so 12, we simplified this yesterday. So we should be using this now. We already have the intercepts, so plot those. Okay, I want you to try this on your own now to find the asymptotes by hand, include them, and then grab your graphing calculator and finish it. Okay, I'll give you about 3 minutes to try to finish that. Okay, you should be back on 12. Now, domain, you don't have to simplify this. We never have before. That's for the intercepts and the VAs. But when you find the domain, it's what values of x do not work for this original function. -1's a problem. 4 is a problem. So those are our restrictions. Okay, but yeah, when we go forward and get the VAs, now simplify it. We're going to use this. The 0 here is going to be x equals 4. Okay. Same thing with x-intercepts. We're going to use the simplified form. Remember, the zeros in the numerator are your x-intercepts, and that's no zeros. Okay, now this the degree is smaller up top, no matter which one you look at. So that's at y equals 0. So draw those in there. Y-intercept right there. VA. Horizontal asymptote you won't really be able to see, but it still might be a good mental reminder to try to draw it. Let's go right here. Right? Maybe extend it past the line so you see it a little bit. That might help you. Okay, and now we're ready. Got the skeleton on paper now. We're going to grab this graphing calculator, punch it in, make sure you close the top, close the bottom with parentheses again, and then just trace along to get some turning points. Because once again, I don't really know what that is. Your point doesn't have to be exactly the same as mine, as long as it's on the graph. Okay, so I just wrote down these 2 points for part D. Plot them and then fit it. Okay. All right, so 4.7, 1.4 is here. It's running along this VA. Let me use pencil for this, just in case I screw it up. Bend it along the HA, which is at y equals 0. Draw arrows to show it keeps going. There's that part, and then I'm doing kind of the same thing here, this shape through this point. And through the y-intercept. Kind of forgot about that. All right, there. Okay. All right, so there's that graph. Okay, before you try to finish the last one, here's a reminder. When the degree of the numerator is exactly 1 more than the denominator, there is a slant asymptote. On December 17th and 18th video, we covered this. So that happened here. So how do you find it? You divide the functions. If synthetic division is an option, great. Do it. If not, you got to use long division. Okay? So that's what you're going to, that's the scenario you're going to have on 13 for the slant asymptote. All right, so go ahead and find the domain part A, find your asymptote C. There is no HA as you're going to about to find out, but there will be a slant asymptote and try to draw that on there. Go ahead. Okay, here's the domain. X can equal -1. Plot your intercepts that we found yesterday. There they are, 2x, 1y. Here's your asymptotes. And when the degree is higher, we have no HA, but there is a slant asymptote. All right, so remember, this works when you divide by something in the form x minus k. So x minus a -1 is x plus 1. So we need to make sure that's -1. All right, so there's the division work. You ignore the remainder, and you use this to get your y equals mx plus b slant asymptote. Okay, so here's what you do. Just like we've graphed linear equations since Algebra 1 or pre-algebra. Go to +1 on your y-intercept, that's b. Go right here. And then use your slope of up 1 over 1 to get your next point going. So up 1 over 1, up 1 over 1. Maybe even go down 1 if you want in the other direction. And then this is a dashed line too, just like your other asymptotes. Okay, so that's how you include a slant asymptote. Divide it, get your line, draw it in there. Okay, and now you can kind of see how this is fitting. This is why this part of the graph has this weird bend to it. It's right along that line, y equals x plus 1. Same thing up here. Okay, so it's going to look like this. This has a VA, so we're starting up here. It's coming through this x-intercept, and then it's running along this slant asymptote, just like that. Okay, you got that? I didn't need an additional point. Part D is if you need to. I already have one. Same thing over here. I have 2 intercepts and asymptotes, so I don't need more points. Start down here, take them through these intercepts, and run it along this slant asymptote. Okay? All right, so when you do your OTI, don't just show the graph, show this process here.